Hi, it's Patty with Thronatisca, and hopefully you can hear me over the background noise. But we've got some interesting facts that we can learn about light just from using old aluminum cans. Now, remember that when we see light, that means that it is reflected back. So for example, this orange can is reflecting orange back to my eyes. It's absorbing all the other colors. We know that white light is composed of red, orange, yellow, green, blue, and violet light. So all of these combined, in science terms, make white light. Now the absence of light, in science terms, would be black. So when you're looking at this black can, it is actually absorbing all of the wavelengths. When you're looking at the white can, it is reflecting all of the wavelengths. So let's see how the light translates into heat energy. I'm doing a little experiment here, and these cans have been sitting out for a while. First of all, I painted my cans. These are just regular Coke cans. I painted them all the different colors of the rainbow. I painted black. Remember, this is absorbing all of the colors and reflecting no colors. The white is reflecting all colors and not absorbing colors. What I want to do is I want to make a prediction. Which one of these do you think will have the hottest water when it sits out for a while? So we have a lot of great things with this experiment, especially the scientific method in terms of controls. Now, you've heard of controls, and there's some things that we have to control about our experiment. Obviously, it's not going to be the background noise, but we have to control the amount of water that we put in here because we're going to be testing temperature. So we have to leave everything else the same. We're looking at what is the temperature whenever it's in different colored cans. So we're changing the color of the can, and we want to see how is the temperature related to the color of the can it's in. Now, so I have to control the surface that it's on. I want all of these cans to be on the same surface. I don't want some of my cans to be on a different surface, or I would be measuring a different variable. I also want a clear container of water so that I can use this as a control. What would the temperature be if it were not in a can of a particular color? So when I first put this out here, the water was 78 degrees Fahrenheit. I've let it set for a while, and it is 92 degrees Fahrenheit in this clear container. All right, so I'm going to take the temperature. Now I have a terribly ugly thermometer here. The digital thermometers work best. When I take the temperature of my black can, so while I'm letting my thermometer work, I want you to make a hypothesis. Which one will be hottest? Will the black be hotter than the white? What about the colors? Will the red be hotter than the purple? So keep in mind that what we see is what is reflected. The red is a low energy wavelength. So this is reflecting back a low energy wavelength to my eyes. And this is reflecting back a higher energy wavelength to my eyes. So my black can is absorbing all the colors. It is 108 degrees Fahrenheit. So if I were to leave an animal in a black car today for a couple hours, you can imagine how hot it would be. Now, the white can, it's going to take a little while to get it to the right temperature, but it's already going to below 100. So it's at 96. All right, so this one was 110 and this was 96. That's 14 degrees difference between the black and white. Now, let's see. Let's compare the red to the purple. I bet you made a hypothesis saying that the black was going to be hotter because you knew it absorbed all wavelengths and the white was going to be cooler. But now, I wonder if this is going to stump you a little bit. Okay? Make your hypothesis. Do you think the red is going to be hotter than the purple? So the red light that we see is a lower energy wavelength than the purple. My red is still going up. It's at 102 right now. Okay. Obviously, you can see why the digital thermometers will work a lot better. So what are you thinking? Do you think that the purple is going to be higher or lower than the red? And my purple is right at about 100. So what I want you to do is to try to explain, why was this one 110 when this one was about 96? How did the light affect it in the absorption? Why was this a little bit hotter than the purple? And I want you to go back and I want you to do this at home. All you need are cans, some craft paint, water, and I want you to come up with some different variations on this experiment. Does it matter how much water you have in there? Does it matter the type of surface that you're doing it on or the time of day? How do these other colors? Can you predict what the temperatures of these other colors will be? Always remember that a good science experiment leads to a lot more questions than answers. Have fun!